Hello everybody, this is EstimationClim Advisor here. In this video we are going to study the fundamental of heat pump and how it works. The beauty about the heat pump is that they can work both in heating and cooling cycles, meaning that they can pump the heat from already cold conditions outside the house during the winter into the house, and during the summer they pump the heat from inside the house towards outside the house. And this way it makes the outside the house medium, whether it's in air or water, even hotter. There are many types of heat pumps like air source heat pumps, geothermal heat pumps, ductless split systems, but they all work with the same principle that are going to be explained here. In this video, we're looking at air source heat pump. The main components of a heat pump are two heat exchangers. One is inside the house and the other one is outside the house. Depending on the cycle, one is called evaporator because it's evaporating the internal refrigerant or working fluid from liquid to gas phase, and the other one is condenser because it is converting the internal working fluid from the gas into the liquid. So a condenser and an evaporator. There is a compressor which is pressurizing the working fluid, and there is an expansion valve which is responsible for dropping the temperature at the constant pressure. Let's have a closer look at what's happening inside the exterior unit, or the evaporator in this case. The external unit is essentially a heat exchanger. It is exchanging heat between the outside air and the internal working fluid through a series of pipes with fins to augment the heat transfer, which are called coil. Let's follow the internal working fluid journey in each cycle. The internal working fluid is passing through the yellow expansion valve, and by doing so its temperature is dropping to minus 11 degrees Celsius in this case. As it travels through the various coils, the air is blowing around the coils by means of a fan, and the working fluid absorbs some heat from a minus 1 degree Celsius temperature air because it's hotter than minus 11 degrees Celsius. This is a fundamental thermodynamic law that the heat is always transferred from a higher temperature source to a lower temperature source. In this case, the heat is transferred from minus 1 degree to minus 11 degrees Celsius. And because the working fluid is absorbing this energy while keeping its temperature at minus 11 degrees Celsius, it's turning into a gas from liquid. Finally, the working fluid enters the compressor. As its pressure is increasing, its temperature is increasing from minus 11 degrees Celsius to plus 35 degrees Celsius. This heated working fluid is now pumped inside the house. Let's go back inside the house to see how this heat is brought to the rooms. So while this heated working fluid is traveling from the external unit towards the internal heat exchanger, it needs to be well insulated, otherwise it's losing some of its heat. This is where you see some black insulations around the pipe. Alright, let's see what's happening inside the air handling unit, which has a fan to circulate the air, an electric or gas furnace, and the heat pump heat exchanger, which in this case is acting as a condenser. We have plus 21 degrees Celsius return air coming from return ducts. While it's going through the coils, which are at plus 35 degrees Celsius, it is getting heated and its temperature increases from plus 21 to plus 36 degrees Celsius. Finally, it's blown to the supply ducts and pushed back into the rooms. The internal working fluid is converting from gas to liquid phase, and by the time it's leaving the heat exchanger, it is a liquid at plus 33 degrees Celsius. Then it is going to the expansion valve to drop its temperature back to minus 11 degrees Celsius. as we talked about. And that's the end of the journey for the working fluid in one cycle. The cycle repeats on and on until the room temperature is reaching the target level. So we learned so far how the heat pump can extract heat from -1 degree Celsius outside air and be able to heat plus 21 degrees Celsius inside air into a plus 36 degrees Celsius. That's the magic of the heat pump. In another video, we're going to compare the heat pump heating to electric baseboard in terms of heating efficiency. As we discussed, the principle is the same for geothermal heat pumps. The only difference is that instead of the outside air in geothermal heat pumps, the medium can be water instead of air. We prepared conditions thanks to the thermodynamics of the heat pump that we can absorb heat from earth in the geothermal heat pumps or air from the air source heat pump in the middle of the winter to warm our houses. EstimationClim finds you 3 verified contractors to install heat pump or any heating or air conditioning systems. EstimationClim is an unbiased consultant that stays with you to evaluate different options for your needs with providing technical and financial advices so that you can choose the best price and quality with peace of mind. Thanks for watching this video. See you next time.